embedded controller lab. We will look at today how to simulate controlling the DC motor program using Proteus. So first we need to look at the PWM register again for LPC2148. So in your program, in the program given in your lab manual, so we are making use of two PWM channels, respectively PWM1 and PWM4, due to which we will be using match registers MR1 and MR4. And in this case, for the LPC2148 microcontroller, we will make use of the PWM channels PWM1 and PWM3. So if this channels needs to be selected, then we need to configure your pin cell 0 register, and because pin cell 0 register is meant for configuring your port 0 first 16 pins. So P00 is also PWM1 and P01 is also PWM3. To make this PWM1, so this two bits, the first two bits, its mode should be set as the 0th bit should be made 0 and the first bit should be made 1. So 2 is a value to trigger PWM1. Similarly, to trigger PWM3, we need to take the value of bit 2 as 0 and third bit should be made 1. So the value which we load happens to be 1010. The first 4 bits, 0, 1, 2, 3 bits, you make it as 1010. So the value loaded A into the register pin cell 0 register. So that will ensure that two PWM channels you are using, PWM1 and PWM3. So due to which in your program, first your delay remains as it is, and your header file should be modified. LPC21XX you are supposed to use, and duty cycle is defined. And here we set the directional flag onto the port 0 as 7. The reason is we will be making use of the 3 pins, namely P00, P01 and P02. So P00 and P01 are alternative mode PWM channels they are, and the third pin is meant for enabling the motor driver which we will be using to drive the DC motor. So the 3 pins, so all are configured as output port. So these 3 pins correspondingly are made 1 and remaining are made 0. So this is 7 addressed, whereas in the program, lab program, we have defined it as FF. So this is one difference, and the FIO pin was set to 2. Now why would the equivalent way is we set it as 4. So FIO pin is also IO pin 0 for LPC2148, and here the value we load is 4. 4 implies that is 00, 01 and 02. Port 0 second P02 pin. Okay, port 0 2 pin, it is made 1. So that is for enable. So there you make it as 1, send 1, which means the pin is driven high, so it reaches the enable pin of your IC. So 4 it is. So 100 implies P02 is 1 always. Then we use pin cell 0, and in pin cell 0 we load the value A. So I have already addressed by A it should be. So we will be using P00 and we will be using P01. To configure P00, we will use 10, the bits 0 and 1. Similarly, to configure P01, we use the pins 2 and 3. So 1010 value. Then 1 2 no change, so you do not have to verify this value. PWM TCR, PWM MCR remains same, and this delay have increased, made 15,000, so that to some extent the motor will rotate with good speed. And no change here, no change. So just remember, only modification where you need to do is on pin cell 0, and pin 0 we have used. These three first three lines, because the pins are different now, due to which these three lines are different. Then the same program, we will be using PWM MR3 and PWM MR1, because PWM 1 channel and PWM third channel is used here. So no change with respect to the remaining code. So these three lines we need to look at. Okay, and going back to the Proteus schematic, so this part remains same. Battery you require, capacitors you require, oscillators you require, this oscillator. And on to the right hand side of this IC, I have used ULN293 or L293D driver. So I'll just show you the various component, how to pick this component, from where to pick this component. So I'll just move on to place pick device, and here you just type L293D. So you're gonna get the motor driver DC L293D. So this you have to pick. I have already picked it over here. The second is this DC motor. So go to pick device, type DC motor. So you have two DC motor, simple DC motor, any one you can pick. I think I've picked this one component, motor active DC motor. Okay, any one you can pick among these two. Then the next component which we will pick happens to be the supply voltage, which you need to give it to the motor. So you have two supplies to be given to this IC L293D. One is the IC voltage or chip voltage, which is 5 volt, which has to be given to pin number 16, and pin number 8 motor DC motor voltage you have to supply. So it is given with the help of this generator mode, and in that pick DC. Okay, and change this mode to okay, one second. I'll delete this extra stuffs. Okay, so here you can just double click on this. Here the voltage is set to 12 volt. So this much you have to do. And next what you have to do is you have to compile this program, build this program, rebuild it again after this. Okay, and the hex file generated will be dumped onto this IC. Before that, the connection between the microcontroller and L293D we will discuss. So P00, this has to be the PWM1 channel, and PWM1 channel is connected to input 1, and PWM3 channel is P01, and it is connected to input 2, and enable, it is connected to P02. So these three pins we will make use of your microcontroller. After this, double click on this IC and select the hex file which you are supposed to load with. This is a hex file which has been loaded now. Give OK and then start simulating. So now the motor will start to rotate in one particular direction. So you can observe the speed. It starts with a low RPM in anti-clockwise direction first, because PWM3 is enabled first. Then slowly the speed of this motor is increased. It will go in this direction for a while. After a while it will halt, it will stop completely. Then it will start rotating in another direction. Initially the speed will be low, then it moves fast. After a while it repeats the process. So as you can see now, the speed is still increased, and after a while, probably after 5 or 10 more seconds, it will start rotating in another direction. Okay, so we'll see when it will start to move in another direction. It's moving in same direction now, but the speed is increased. It's rotating with high RPM now. Okay, now it has stopped. It will slowly move in other directions. So this is what the experiment is about. So you are supposed to control the speed of the DC motor using PWM channels. Hope this makes sense. Thanks for watching the video.